you walk the stage. That's what matters. It's not always just about what's on the screen. Am I wrong, judges? Because one of the criteria here is communication. So when you're going to the international level, you can't be saying, no, no. You have to own the stage.
I'm sending it to Google Drive. If I can get it, I'm sending it to WhatsApp, but I cannot send it.
So, this is what we're going to do, right? Today is Friday, and there's Friday prayer. So, we're not going to sit now waiting for microphones, right? So, if you're not looking to present, you're not looking to present until you get microphones, right? Olaoluwa. Honestly. Can you all just sit in the room? I'm not going to be looking for them. My patient is wearing thing now, honestly. Okay. But are you okay to present? There's a lot of
Let's just set the room. If we're not going to use the machine, we're not going to use the machine.
Okay. Okay, so Blanket, I'll call you, come on your presentation without the microphone, okay? Because if you can hear me, you should be able to project this thing. So, yeah, oh. You okay? Judges, are we ready? Yeah. So you can, from the agenda, you can see their name and the title of the paper for your instructions. In case it's too far. Okay. Okay. Yeah. That's what I'm saying.
Yeah, just wait. We'll tell you when to start. And there is just time to pick up the name and the title stuff and ask them to proceed.
Judges, are we ready to go?
Probably what you should do, instead of writing down the full title, just use the paper number.
Not all of them put paper number. Not all of them put paper number. Okay, just use their names instead of writing out this. Because it's long. Just use their names. Just names. Yeah, just names. Okay. Okay.
Alright. You can go ahead.
Thank you. Good morning, each and everybody. I'm SAASC from Tanzania, representing my project title, which states that growing up bacteria by using daily organic household waste materials and applying them in oil spill recovery. As it's known to each and everybody that the oil spills tend to devastate our environment and endanger ecosystem as well as wildlife. And it's where the project title and innovation arises that we can use our daily organic household waste materials in growing up these bacteria and then implement them in oil spill recovery, both offshore as well as onshore. And the main objective of...
Sorry, can we stop moving around when you're presenting, please, so they don't get distracted?
Yes, please.
Can
Just show nobody comes in from that door.
Yeah, just shut the door so they don't distract them. I won't just sit down.
Can you just catch your breath and just start all over again? Catch your breath and start all over again. Sorry for the distraction.
Okay. The objective of this project has been categorized into two main objectives, the primary and specific objective. The main primary objective of this project is to investigate how we can use the the daily organic household waste materials from our home teams to grab the oil-eating bacteria that can end up oil spills. And also, the specific objectives of this project is to identify that several strains of bacteria that can be used to recover the oil spills in both offshore as well as onshore areas, and also to determine the rate as well as the efficiency of these several strains of bacteria that are capable of degrading oil spills, and also to assess the cost-effective and also to assess the cost-effective as well as environmental effectiveness of these strains of bacteria within our environment as well as cost, and the relevant significance and challenges. The significance and relevance of this project is that it's very sustainable and costly, very sustainable.
Quiet.
Just continue.
It's very sustainable and cost-effective method comparing with the current oil spills recovery methods that have been used, including the mechanical recovery, in situ burning, as well as chemical oil spills recovery, which is very toxic to our environment, both offshore as well as onshore. And also, it offers the waste reduction since we tend to use the organic household waste materials from our homesteads, and also it's very applicable in both offshore as well as onshore. Though it can vary in scaling up, and also it contributes to development of eco-friendly technologies that can reduce the oil spills from our environment. And the challenges of this project, we have scaling up. It's very hard, especially in large scale. Take the picture of deep sea horizon, and also managing several factors such as temperature, as it's not function well within low temperature environment, these bacteria and also these bacteria, they tend to produce several harmful products such as ketone, alphatic acid from alphatic hydrocarbons, and also aldehyde and phenol, and also incomplete degradation of these hydrocarbons can result to the production of harmful materials. And the methodology of this project is laboratory experiment and we have the methodology number 1, number 2, and number 3. Number 1 is waste preparation. Is we prepare the several waste materials, especially those rich in carbons, such as fruit scraps, as well as vegetable peels, and also the bacterial cultivation. We have mainly 3 steps, which is inoculation, incubation, and aeration. Aeration is a condition that we need air during this process. At inoculation, we introduce the several known strains of bacteria within the organic waste materials, so as we can grow them. And also incubation, we just start growing up these bacteria within our organic waste materials for some few weeks and a few days. And harvesting, we have several processes, such as settling, decantation, and concentration. In terms of concentration, we can use centrifugation machine, or we can filter by using filter products or cheesecloth to separate the bacterial slug with the lighter material. And in settling, as it's known to each and everybody, these bacteria are very heavier compared to water content. Therefore, we will settle at the bottom, and then the top layer will be removed. And decantation is the same. That we remove the top layer and remain with bacterial slug. And methodology number 3 is oil degradation testing. We test the capability of these grown bacteria to degrade hydrocarbons. And results and discussion, we assess the two factors, such as temperature and nutrient availability, towards growth of these bacteria, as I have stated before in my objectives. I need to know the growth rate as well as the efficiency of these bacteria. We tested here by using approximation volume of bacterial slug within the organic waste materials. And also we tested the bacterial degradation rate through concentration of these bacteria. As the concentration of bacteria increases, the oil degradation rate also tend to increase, and the number of days also might be few. The application effectiveness in monitoring, how we can apply these grown bacteria. We have direct we have direct application. Yes, we can apply the bacterial slug within the affected oil spill area. And also, we can spray the bacterial slug within the affected area, especially onshore areas. This can be applicable. And also, we can mix with absorbent, especially in onshore areas. And also, the effectiveness of these growing bacteria depends on type of oil, the type of oil spill, several environmental conditions such as temperatures, I have said before, and also the concentration and type of bacteria being used. And the conclusion and recommendation is the organic waste materials can be used to grow these bacteria and implement them in oil spills. And in oil spills recovery, yes, I have investigated. And also the oil spills reduction. That there are several strains of bacteria that we are choosing, like Bacillus SSP and Alcanovorous bacteria can be used in oil spills reduction. And also, this method is very cheap and green compared to other methods being used. As I have said before, we have in situ burning, we have chemical recovery and mechanical oil spills recovery, which is time consuming and also very costly due to the elongation of time. And also, it's very environmentally friendly compared to recent methods being used. And I recommend the further research towards application of these bacteria, and maybe can be used in enhanced oil recovery methods. I don't know. I recommend further research for this bacterial applications. And I would like to acknowledge each and everybody for listening me, believing me, and also giving me this opportunity. Thank you for listening.
Okay, please, sir. Well done, good job. First, I want to appreciate you for this delivery. This SAASC, that was from Tanzania, arrived a little bit late yesterday and had little time to rest before the presentation. Good job, well done. Typical at the African regional level, our job is not just to comment, but to also help you point out areas you need to improve the work. So the judges will be giving you the observations to help you further improve your work. First and foremost, you need to work on your presentation skills. I see that there was a little bit of disconnect between, it's your slides. You prepared it, right?
Yeah.
There seems to be a little bit of disconnect between what you're trying to say and your slides. The slide is before you speak to your slides. You don't necessarily have to memorize the entire slide. That's not the essence. Yeah? I didn't see you provide some level of definitions. Okay, so in my own simple term, what is, for example, oil spill? Oil spill. Your research is around oil spill, correct? Oil spill. Crude oil spill.
Crude oil spill.
Yes, what is it all about? Can you just give us a little bit of explanation of what it is all about?
Crude oil spill?
Yes.
Crude oil spill refers to environmental pollution that caused by the accidental using of crude oil. It's whether onshore or offshore.
Okay.
The release of crude oil content within environment. It might be offshore or onshore. And mostly it's accidentally. Means not done purposely.
Well, all right, so I'll allow that judges to ask questions, please.
Thank you for the presentation. As Andy said, like, was encouraging and to see the area that there's some teaching that you to add. One of those slides, we have the slide number, citation, reference, each reference, because having basically citation, science, different reference from you, different other people's teaching, and that have knowledge. So our knowledge is also show reference, not necessarily to all reference, two reference that you can have. And also there should also be the body of methodology, literature review, and maybe it is homework, table, title, author, title, method, result, and gap. But then you have at least somewhere of 10 literature review in 10 years. Now people now see the gap in the trying to solve. People talk about top notch. Medium of it. Like you said, my first comment is your slides are not numbered. So it's a big challenge. Judges, they want to take it back slide number. Sorry. So I have one question. You have to identify the type of bacteria after cultivating. What is the type? What is the name? I don't have any of the bacteria.
SAASC herbivores. SAASC herbivores. Yeah.
It wasn't written in the slide, was it? Was it written in the slide somewhere?
It wasn't.
Huh? It wasn't there, yeah?
It wasn't yet.
I don't think it was not there. I didn't see it. That's why I'm asking.
Okay.
So how do you identify it? How? How do you identify that this is the bacteria? You understand the question?
Yes.
The bacteria, yeah? So we take the cultivated bacteria. We say, what is the name of the bacteria?
SAASC
Okay, so how do you come up with that name? How do you identify this bacillus?
I went through literature review. I read it then. I suppose by these bacteria, they are sold.
Okay, so you went through literature review. You identified that this bacteria is called bacillus in literature review.
their similarities in terms of
You have to go to the lab. You went to the lab. That's what I said.
Yeah, exactly.
You went to the lab. You use microscope.
It's the same bacteria. That's what I was saying. How did you come up with the name? You test the chemical properties and you found out that each of them have the same chemical properties as from the review before.
their working conditions are as it is.
No, you don't do that. Every condition doesn't mean that they have the same chemical properties. Probably just one factor can make that. What did you show you? What did you show you? Which teacher? Did you give any paper? Paper? Journal?
There's books and articles. And then after reading
So there's need for you not to go to that.
You say you can just go back to challenges. There's a slide with challenges that you just answer. Yeah, so 5 for the production of agriculture and the particular system and having flow. How do you identify that there are 5 for the bacteria?
serious.
Yeah, how do you come up with what's the 5 for?
Yes. The oil. Aliphatic hydrocarbons in it. It's known. And then we apply.
I think, see, one thing you should know is, if you don't have an answer to the question, be honest enough to tell us, okay, I will look into it. You understand? And you just start starting on here and doing something. So, I hope when you made a good presentation, it's not easy to stand before a class to make a presentation. But when you do your work, be able to marry what you have done with the content, what you have presented. Now, I just want to also draw attention to what you put in your conclusion. Put your conclusion. Put your conclusion. You said one of your conclusions is that it will reduce oil spill. This is totally out of positive. Because you are trying to use the oil spillage to use waste to maximize or to stop oil spillage or to prevent oil spillage, isn't it? Not that your project will reduce oil spillage. Oil spillage like event and accidental event that has happened, but it's, you know, your project wants to use waste to clean up oil spillage, isn't it? So again, use bacteria to clean up the oil spillage, not to prevent the oil spillage. Thank you for your discussion.
Let me just quickly round up if you don't mind. So, Mr. Isiaka, I want to thank you for coming. And you had a long flight maybe, and I just hope you learn from the observations, and especially presenting this. I think you can do better. This is a global state issue. It's not a Tanzanian, East Africa, West Africa. You're going to Houston or Texas, and you need to be. I want to encourage you. From your last work, you mentioned that further studies should be done. I think we all struggle to understand what you intend to achieve and the objective. And I think you can do better. So grease up. We hope to see you again. Have a good day.
just a couple of household if I call the next question. One, can we please stop moving around when presenters are presenting because it can be quite distracting? And you'll just put your phones on silent, please, so that we don't distract the presenters. And so next question is Olaoluwa Oboro from University of Lagos, and the title of his presentation is Mitigating Corrosion in Oil Pipelines with Moringa and Bitter Leaf as Eco-Friendly Inhibitors. Olaoluwa.
Ola, please go back and give us 1 second to tell you what you said. Alright, please go ahead.
Also, my name is Oboro Olaoluwa Samuel from SAASC I'm presenting on the paper titled Mitigating Corrosion in Oil Pipelines with Moringa and Bitter Extract as Eco-Friendly Inhibitors. So discussing from the documentation in the past, the environmental study, the problem statements, the objective of research, and down to the result discussion and conclusion, which includes the qualitative and quantitative analysis of this research, and also how Moringa and Bitter Extract can be applied in a real-world oil and gas industry setting. Also, so discussing on the cost-benefit analysis, the challenges that might face when employing this solution and how these challenges can be addressed. So as the world relies on crude oil increases, also the oil and gas industry also rely on pipelines. And pipeline is a pivotal asset, a key asset in the oil and gas industry. And as much as it's a big asset, a vital asset, it is prone to severe failure. And this severe failure can be largely attributed to corrosion. Because of corrosion is simply the monetary effort made by a nation in minimizing corrosion. And according to NIST International, one of the world's leading authorities in engineering and corrosion, they confirmed that corrosion cost the USA oil and gas industry about $1.4 billion annually. And also, it was confirmed that in the space of 10 years recently, the Canadian oil and gas industry reported more than 9,000 breakdowns of pipelines due to internal corrosion. Those data, $1.4 billion spent annually by the US, and also 9,000 breakdowns in the Canadian oil and gas industry, shows that corrosion is a big deal and a big threat to the oil and gas industry. Now, there are consequences that can be faced of corrosion. One of them is the increased greenhouse gas emission. So I'm about to say something, I'm expecting a response. Thank you very much. The clean energy that SP is advocating for, another environmental conscious body are advocating for, is constantly and consistently battled against by corrosion. You can see that corrosion causes increased greenhouse gas emissions, even down to the economic impact, the production loss, and even the increased operating costs. There are factors that influence corrosion that catalyze corrosion, which includes the physical factors, the environmental factors, and even the chemical factors. That is, there are inherent properties in the oil that is being transported that catalyzes corrosion. We have the H2S, the CO2, the chemical variables, the microorganisms that catalyzes corrosion in the oil and gas industry. Also, here you can see, each of the corrosion. Here we have the top line corrosion, here we have the peaking corrosion, here we have the under, the consistent corrosion, and here we have the mesa attack. So total we have about 20 forms of internal corrosion, which my paper is going to focus on internal corrosion. So here we have income corrosion, peaking corrosion, corrosion. Total we have 20 unique forms of corrosion. Imagine the number 20. That shows that corrosion is a big deal in the oil and gas industry. Over the years, there have been a conventional strategy in fighting this corrosion, which is the use of synthetic inhibitors, that is chemical inhibitors in fighting against corrosion. And although it has demonstrated competence in fighting this corrosion, but despite it has limited impact on the environment, and therefore it has made us that it is necessary for us to find an alternative solution in fighting this problem, which is eco-friendly solution. This study is focused on using moringa leaf and bitter leaf extract in fighting previous corrosion, and the objectives are to explore the feasibility of using moringa and bitter leaf as main inhibitor, and also to develop a robust framework of applying MLE and BLE in the real-world oil and gas industry setting, which other research papers fails to account for. Also, we have proposed a framework that was not present in other research works. So, while working on this paper, we reviewed several literature, but spaces we can just list out about 4 of the papers that we reviewed. And one of them is Adibashi. In the 2023, we discussed on how we worked on new steel on H2SO4 acid and NOH acid for 28 days. And the gap in research was that there was needed environmental conditions like temperature and fluids. Also, Uchenna worked on electrochemical impedance in determining the effectiveness of BLE. BLE means bitter leaf extract. And one of the gaps in research was scalability issue, which our paper is focused on closing that gap. Also, we need to notice our respective here, work on corrosion, work on using banana leaf and the comparative analysis of bitter leaf and banana leaf in fighting against corrosion. And also, we should also use the international adsorption ICTM he worked on that in fighting against corrosion. And the gap in that research, the major gap in the research was that lab scale may not translate to industrial scale application. Therefore, our research is focused on closing gap, closing that gap, ensuring that there is an industrial application of this extract, this plant extract in the oil and gas industry. So what did we use in this paper? We used the documentric method, which is the weight loss method. Because it offers high precision indicator accuracy and not just offer quantitative analysis but also qualitative analysis, meaning that you can see and tell with your eye that okay, this indicator has the ability to fight this corrosion better than the other one. And why do we use moringa leaf? We use moringa leaf because of its inherent properties and the oxidant properties like the ascorbic acid, the flavonoids, the phenolic cataloids, and also for bitter leaf we use it because it has the polyphenols, nanophosphate and flavonoids. So we use milk steel, which has a carbon content rate of 0.18% to 0.23%. And how do we obtain the extract from the moringa leaf and bitter leaf? We obtain the extract from both plants by immersing them into 30 ml ethanol for good 12 hours. So after immersing them, the filtrate, we apply it by brushing on the milk steel. So we apply the filtrate, the extract that we immerse the extract of MLE and BLE into. We apply it by brushing on the milk steel, and we did it for different concentrations, the 9 ml and 15 ml for both MLE and BLE for us to do a comparative analysis of which one works better and has better efficiency. We found out the corrosion rates by finding the weight, by measuring the weight, initial weight before the immersion into the corrosive medium, and also the final weight after the corrosive medium. And these are the formulas we use in finding our corrosion rate and also our individual efficiency of this research paper. So here, this shows us the result and discussion of this paper. So here you can see that this is 15 ml, this is 15 ml, and the 9 ml. So this is the best graph is showing all the individual efficiency in fighting against corrosion. And you see that the 15 ml has the highest number, meaning that's the highest rate, that's the highest inhibitive efficiency, showing that the more the concentration of the inhibitor that is applied, the more it has the ability to fight against corrosion. Also, here, the one below is shows the rate of corrosion graph. And yet, you can see that the 15 ml has the for both MLE and BLE. MLE is moringa leaf extract, BLE is bitter leaf extract. You can see that for both for the 15 ml for both BLE and MLE, they had the least rate of corrosion. And significantly, 15 ml of MLE, the moringa leaf extract, showed up as the least compared to others. Compared to others in fighting against corrosion, meaning that the 15 ml of the MLE had the slowest rate of corrosion compared to that, and the values for the efficiency of the 15 ml MLE is 70.17%. That is the other efficiency in fighting against corrosion, and also for the 15 ml, we can see that it has the least rate of corrosion. So this diagram there is showing us how the absorption mechanism of the inhibitor that's applied. So you see that when the inhibitor is applied on a male steel, so that inhibitor is serving as a barrier between from the interaction of the corrosive agent and the metal. So the thicker the inhibitor applied, therefore the more slower the corrosion rate, the more the inhibitor has more efficiency in fighting against corrosion. So this shows us how the absorption mechanism works. That the thicker the protective layer, the slower the corrosion rate. And also, this diagram is showing that this experiment was fully performed, and you can see that this is the 15 ml, and this one is like the 9 ml. So this 15 ml has less scale. So that's less scale that you can see at this point there. While the 9 ml has greater level of scale, showing that 15 ml produced the slowest corrosion product, which we have lost. It produced the slowest corrosion product compared to the 9 ml. Yeah, showing that the 15 ml applied to, but this is the 15 ml applied to one container. This is the 9 ml applied to one container. So yeah, the 15 ml, and remember I said that we use gravimetric method because of it has both qualitative, meaning that you can tell from your eyes by just seeing that okay, this method is best for fighting this corrosion. So this is the qualitative analysis of the experiment that was performed. So the CBA, so we have the availability and the cost effectiveness, meaning that moringa leaf and bitter leaf is readily available in every climate. Also, the green branding, ExxonMobil, Chevron, Shell, come closer. You see, applying this solution, applying this method of bitter leaf and moringa leaf extracts can enhance your brand image, therefore serving as green branding and appealing to environmental conscious investors and environmental conscious consumers. Therefore, in a large scale, it will boost the revenue of the oil and gas operator companies. Also, community and economic development, and also by extension, we have food security, meaning that the more we leverage on these plant extracts, the more food security we have in the nation. So this is how we apply this. This is how we apply this in the real world oil and gas industrial setting. So let's assume that we need just 5 ppm of inhibitor to fight against corrosion in a single pipeline, just one pipeline. We need 5 ppm inhibitor. ppm is parts per million. Therefore, for a pipeline transporting 1 million barrels of crude oil, which is 1.9 million liters, the annual inhibitor that we needed is 795 million liters of inhibitor. Therefore, if the inhibitor is similar to water, we have 795 kilograms. Now, the annual cost of these inhibitors, that is the synthetic and the moringa extract. Therefore, now the synthetic inhibitor, we start got us to find out that there is the most used inhibitor is limazogene-based compound, which is a synthetic inhibitor, and it costs us about $0.5 per kilogram. Now, the annual cost of using that for a pipeline will be $297 annually, while for moringa extract, which costs about $0.03 per kilogram, the annual cost is about $23.85 annually. Now, over a 20-year lifespan, let's look at that over a 20 years lifespan, contributing in a real world oil and gas industrial setting, right? So now, for synthetic inhibitors, which is the conventional, the traditional inhibitor that is being used in the industrial setting. Now, we have for 20 years, we're using it in Naira to bring it in our understanding. We have over 12 million Naira synthetic inhibitor that is being used. And for moringa extract, we have over 739,000 Naira inhibitor that is being used over a 20 years lifespan. Now, this means that when we are comparing both synthetic and moringa extract, you will see that the industry will save themselves a staggering 11 million Naira difference. They will save themselves 11 million Naira for just a simple pipeline in this span of 20 years. That is huge. So oil industry can save themselves 11 million Naira just by using and by leveraging on this moringa extract for combating corrosion in the oil and gas industry. Now, the challenges and how we can address challenges. So, one of them is standardization. So, we aim to ensure consistent and scalable cultivation, a standard industry cultivation of this plant, as in moringa leaf and bitter leaf, and also by making sure that everyone is aware that molecular ambientals have inherent antioxidant properties that fight against corrosion. Also, further research can be done to fully understand the inhibitive efficiency and performance of moringa leaf and veggie extract. These are the references that were used for the research paper. I also want to acknowledge my lecturers and friends that made this project a success. Thank you very much.
Judges, you have 5 minutes.
Okay. Good job. Yeah.
No, just
No,
judges.
just thank you. Well done. I love the fact that you are able to give a vivid illustration from your objective, connect your objective to your result, which is very, very good. I also like the fact that you are forcing us to go green. You only mentioned Chevron and the big IOCs. You left out the marginal feed operators and the national rail companies. But good job. How do you apply this, your extracts? Yes.
Okay, I apply it by brushing, like I said initially.
No. How do you apply it? You want to inhibit corrosion in your pipeline?
The industrial.
No, not industrially. Corrosion inhibitors can be injected at the wellhead. You can decide to even inject it at different points. This your extract, is it in liquid form? Is it in solid form? At what point do you inject it? Do you apply it? Do you understand?
Yes, so this inhibitor is in liquid form.
Okay.
Yeah, it's in liquid form. And that's why I said that we use, yes, the university of inhibitor is similar to water. So it's in liquid form that we are working with.
Then allow us to, since you are saying you have 5 minutes.
Then quick one. Did you compare, because I saw you try to analyze the present in terms of financial difference. So did you compare the previous and the present? The efficiency of what you are using or what you are proposing now? Did you compare it with the efficiency of what is being used now?
Of currency?
Yes.
Yeah. Yes, sir.
Did you compare it?
Yes, sir.
So what is the comparison there?
Okay, so for
Not the financial.
Not
In
financial.
terms of efficiency, getting the job done, yes.
So this extract, we use when you apply this extract, and the efficiency was 70.17. 70.17%. And for the standard inhibition, that is the synthetic one, right? It's at the same range of 70 to 80%.
What is it? Yeah, there's no one. What was it? What's the difference?
So we are looking at the environmental impact. Like I said before that the conventional one that is being used in the industry has proven itself to be a great one, but the environmental impact it has on both aquatic, the soil, and all other local ecosystem. So we are trying to fight against. So the major focus is that okay, yes, this inhibitor works, but how about this negative impact that the inhibitor is causing on the local ecosystem? We are trying to mitigate that by employing the eco-friendly. At least they are of the same close range inhibitor efficiency. We believe that this has less, it has dual advantage. It has the antioxidant, which is the property that fights against corrosion, and also the non-toxic property that it is biocompatible with every other it's biocompatible, meaning that it is compatible with any both assets and also the environment of the oil and gas industry.
My question is still not answered. Efficiency rate. Okay, this is 90, this is 80.
Yeah, that's it. That's it. 70 range efficiency.
Okay, thank you.
Okay, just say they're close, but his own focus is the environmental impact.
He's concerned about the
The
environment.
environmental impact, which is the key to profile.
Yeah, well, I wanted to say, yes, a good presentation with time, but whenever you want to, like what they have just noted, you are supposed to make a comparison of the traditional method and what you are proposing to see the effect. If you are saying that you are more concerned about the negative environmental effect,
same range of 70%.
Okay.
It was not clear in your slide. You just said that it's not clear.
So, well, I want to commend you. You have done a good job. And I think, based on your references, you were more current. The literatures that you used were current. That is commendable. But like for important and international presentation like this, make sure your spelling are correct. Introduction was not rightly spelled. Take note of it. So make sure this is an international competition, and you should ensure that everything you are presenting is top-notch. Thank you.
Any other question?
Just on the final addition. Okay, are you done? I just think also that you need to, in case you come up top, the presentation as Prof mentioned is very key. You need to go back and maybe specialize in a particular type of referencing and research methodology you want to be using. You need to focus and be sure what you're, because when you get there, these guys are not joking. They are not joking. That's the truth. They are not joking. They are not joking. They will just skim you out in less than 2 minutes. So I also want to advise in terms of plagiarism. You know, it's very key because these things will be put in systems. So take note. Have a good
A round of applause. We're running out of time. A round of applause. So next up we have Victor Eze from University of Port Harcourt, and the title of this presentation is Eco-Friendly Drilling Fluid Additives, Exploring Molasses as Viscofire and Ground Coconut Husk as Fluid Loss Control Additives in Drilling Fluid. That's a mouthful. Okay, the stage is yours.
Give us a second, we'll tell you when it starts. All right, sorry.
Good morning, everyone. My name is Victor Eze, student from the University of Port Harcourt. So I'm here to share my research on exploring eco-friendly material as drilling fluid additive. But I'm going to focus more on the use of molasses as the fire and coconut powder husk as fluid loss. Moving on. Underrated phenomenon about the use of green materials or eco-friendly materials to substitute conventional additives. Consider the fact that drilling fluid is one of the key material in drilling operation. The underrated eco-friendly performance of eco-friendly material in the drilling fluid operation. So, and the truth is, most of these eco-friendly material are abundant in our environment, within where we stay and all of that. So, leveraging on this background, I think work on these eco-friendly materials that helps in the drilling industry, whereby we reduce costs and environmental impact, their impact on the environment. So, the problem statement now is that the drilling fluid is currently valued at probably $1.2 billion, and that's a lot, and it's expected to reach about $2 million by 2029. And API is estimated about 150 million barrels of drilling fluid waste. And you know, when this fluid are being deposed to the earth or wherever, the impact to the environment is very tedious. So if we can look for a way to mitigate the factors that are going to maximize this impact on the environment, and doing the environment a very good thing. And considering the fact that drilling fluid additives are one of the key factor that aids in the depletion of the environment or whatever. So now my aim is to evaluate the effectiveness of molasses as a viscosifier and the coconut husk powder as a fluid loss additive. So now, during the course of my research, I reviewed several publications and books, but these three piqued my interest. Now, Swigert talked about the soil contamination and how this disposal of this fluid is going to impact on the soil. But the gap between the research was he never mentioned the solutions that was meant to account for the problem he found out. Yes, he did an assessment on the contamination of the soil, but he never mentioned the fact that eco-friendly materials could be used to help depletion of the soil and all of that. So he used coconut husk as previous control active, but he did not use molasses as a specifier to aid in the loss control, because most of these eco-friendly additives they tend to complement each other. Now, they vary the same thing, but do not consider the use of biomaterial for effective performance. Now, these are the methodology to move from the API. So, to verify the necessity of this research, I proceed from using the API technique, which talks about the procedure and steps in mode formulation, the additives and all of that. So these are the guidelines used to effectively achieve my aim. So down to the biological test where I got to check for the gel strength, the plastic viscosity and the heat strength. Down to the diffusion test, this is where you check if the fluid loss additive is able to effectively prevent the migration of fluid information. Down to the mode preparation, the mode modification, where I added my modifiers, and I have compared the conventional drilling fluid additive and that of the eco-friendly additive. So these are the materials and approaches to research. These are the people presentation. So now, the plastic viscosity, the heat the jet stream and the heat point. If we reconcile these parameters, that is when we can ascertain the effectiveness of the viscosifier. So now, that I use the CNC, which is carbon methyl cellulose, to compare to molasses, which is my eco-friendly suggestion. So now, at the 10 millimeter, we have a classification of 14 for that of CNC, that of 10 for e-points, and the jet stream at 10 minutes and 5 minutes respectively. So for the molasses, we have at the same 10 millimeter, we have a classification of 10, which is produced, yes. For the e-point is 9, and all of that. This continues the same way. For the volume at 15 millimeter, same with classification and all of that. So now moving on. Now this is a graphical representation of the result for just the plastic viscosity plastic volume. So this is the change of the plastic viscosity versus the additive volume. That means the amount of additive added to see if there can be improvement in our viscosity. But the truth is there are other things that need to be done to help the molasses improvement performance. So down to the comparison for my use point. The same thing, the CNC outperformed the molasses down to my judgment. But now the truth is, molasses just alone cannot effectively achieve a good viscosifier. That is where the CHP, which is the coconut horse powder, synergetically works with the molasses to achieve a better viscosity. So the combination of both the molasses and the viscosity, so these are the data we've gotten for the CMC at the same 10 volume, we got 18, the fuel viscosity of 18, 22, and at the E-point we got 12, 14, and that's on. So you can see that it's the synergetic effect of the molasses and the coconut oil powder that will prevent to achieve a better viscosity. So now you can see the trend from the graph that now the molasses plus the molasses plus the coconut oil powder was able to outperform the conventional CMC, which is the carboxylate, the carbon of the methyl cellulose, as the normal conventional active. So this performance at the plastic viscosity for the E-point, safety, and that of the jet strength. So this is the comparison of everything we know from down from the CMC, the CMC alone, CMC plus the coconut oil powder, and that of the CMC for 10 minutes and 10 seconds. So now, comparing the synergetic effect reference, so this is it. So this is where we have to check for the two dots. Now we have done with the viscosity. After we try to achieve a better viscosity when we combine the molasses and the coconut oil powder, we got a better viscosity from that. So now that's the two dots additive. So now for the two dots additive, we had to use the polyionic cellulose for as a conventional two dots additive and comparing it to our coconut oil powder. So this is what we got as CHP, PAC, and all of that. The situation was we got 3.6, the PAC we got 3.2, and we put that in 2.4 and all of that. We checked for 4 grams, 6 grams, and 8 grams respectively. So this is what we got. Now, the same thing happened. The pack had performed the CG. And so the truth is, most of these eco-friendly additive might not be able to outperform the conventional additive. but they need either an enhancement or increase in the weight or the quantity of what they do. Now, this is what we have. You cannot have horsepower that does not perform the conventional breeding activity. So this is for the thickness and fire. But now, the truth is, those slides was not added here. The truth is, if we want to achieve a better fuel loss efficiency or fuel loss performance from loss of horsepower, let me say, it's going to be a ratio from a 2 to 3 ratio or a 2 to 5 ratio. So if we are comparing the PAC, which is the conventional breeding additive, so comparing that rate. So what we do is, if we're using 2 grams of the PAC, we're going to use 5 grams of the CHP, because even if we use 10 grams of it, we see that it is more efficient and cost effective than when we see use the PAC. So now, the discussion. And now from the graph, it shows the plastic viscosity, the increase and all of that. The CMC consistency is a bit higher viscosity than the molasses until when it is synergetically combined with the CHP power, the CHP. So the combination of results in higher viscosity than the CMC alone. The fact is a bit better, just like what I said, the fact always is a bit a better good control additive than that of the CHP. But the thing is, if we are to use 2 grams of the PAC, then we have to use 5 grams of the CHP powder. Because if still compared, the CHP powder is very available to get, it's cost effective and all of that. So if we analyze that, we see that at all points the CHP powder, which is cost effective and has less environmental impact, will still be better than this PAC activity. So now, conclusion. Now this, if we try to explore more about eco-friendly additives, we'll see that natural eco-friendly additives are possible to outperform the conventional ones. If they are being enhanced or used synergetically, they will do better. And because if we just feel the conventional additive are going to outperform the eco-friendly one, we might not be able to achieve something targeted. So at every point, it is either the eco-friendly additive needs an enhancement or it needs to increase the quantity of what we are using in our mold. So now, recommendations. Now, we need a real-time applications of this because a lot of research like this has been done, and if real-time application is not being done, we cannot really ascertain or we cannot confidently see that the conventional additive might not be the best. So the real-time application might expose us to a better understanding of how this can work, and we can explore more if you use more of this great material and all of that. So the stability, so yeah, stability talks about the enhancements to help you to help stabilize this additive for a very long time, to help them in different well conditions and different operations. Thank you very much.
Good job, Isaac. I like the calmness. I like the fact initially when you started talking, I was hoping that you were able to land, but you landed well. Good job. I like the subject you raised. Yes, in building we're truly spending quite a lot of money in trying to come up with the right mode formation. What I wanted to ask, you actually concluded on that. Testing this novel idea you just put forward, that there's no proof of work at this moment. And we're hoping that one of the operators or service companies should be able to apply it and see what impact it's going to have. Did you consider the economics? Yes, it's eco-friendly, but do you know whether it is cost-friendly as well?
It's cost-friendly. For example, the CHP, which is coconut box and powder, is more like a waste in every way. It's more like a waste. So if we can leverage on that, we can get those things we think they are waste and we implement them in our drilling operation and all of that. The molasses is a byproduct of sugar, which is, I think, it is less. The gallon is less than $5. Yeah. So if you're saying that the economical part of the additive, the CHP is more like a waste. Most people don't use the box of the coconut. They are being disposed. 90% of the coconut crop is being disposed globally. So if we can work on using those wastes, it's more like you're getting something for free. So there's no economical value of it. So it's more like you just having something at a free way.
But
Thank you for the presentation. Okay, I want to go back to the topic. What is the difference of your data is submitted? And from here, it's not catching. If somebody is not opportunity to see your presentation from the topic you discourage, so from the topic we need to modify the topic to show we are trying to solve a problem that I understand is to maximize our solutions. So we are trying to use ways to solve the problem. The bonuses you are talking about, are you going to produce bonuses or the bank? Or why do you intend to get the bonuses?
Molasses is already a byproduct of sugar. So
How do you intend to get it?
companies who make sugar, they have molasses as a byproduct after the process of sugar, right? So we can get it from there.
I'm sure that they can use this bacteria, this species, and this is the fire. You don't need to do this here. This one to be in your objectives so that you minimize and see how to struggle to catch that. The molasses in this, but you don't need to tell the topic in the title. I get my point.
No, you don't need to explain. I actually wanted to point out that you need to rework the title. Yeah? Just take it as a feedback.
Okay, yeah. I want to make a comment on your literature review. You go to that literature review. Is that how site aspects? What's wrong with that? What's wrong with the way you have written the authors? Yeah. Yes, ma'am. So, and also, it's usually you don't put it this as well. It's only the author who is determined your year.
Yeah, exactly. You can
understand now.
journal name, also the short form, also the words.
At this point, it's just the author, the surname, and the year. This is when what year does it? The first one, what year is the book? About 2013, about. Yeah? Just keep those. Make sure you see wherever website in there.
Also try to at least use recent years between the 3 to 4 years back. Because 2013, that is a long time ago, 11 years ago. So then you consider the complete future. Okay? Try to use more recent, maybe 3 to 4 years.
Is that why you took the year because of the
The very last people is.
Yeah, 2013 is.
But it's right.
What about the second one?
Second one, 2019.
we're very good, Victor, and co-judges. I just think there is already a phenomenon and a chain of consistent issue with research methodology from all of them. It's becoming a recurrent issue, and I want to urge SP to please ensure that whoever wins this, whoever is going, because I can see they are mostly undergraduates, right? Am I correct? Undergraduate, yeah. So maybe most of them have not gotten. So you're already at the stage of doing your research, but I don't know how you are going about it in your school. So I think most of them require a proper tutorial on research methodology. Because you can see from the referencing, it's not okay. You can see from their presentations, you can see the numberings, you can even see, go to the first, let me show you something. Yes, you see now, fluids addictive market was valued at 1.247 billion in Nigeria. Where did you get these figures from? Where? You see, we don't know. When you go to the global stage, you don't go and put this, I don't want to use the wrong word, but you don't go and put this up there.
No, I actually got that.
From where?
No. Just for the, you're supposed to put the.
You put it for us there.
There.
You see?
Just
You cite it. You don't just say fluid addictive. Some of the other guys that were there were also mentioning figures and figures and figures. And I was wondering, I'm hearing billions of dollars, tens of. How did you get that? Are you a magician? We cannot know automatically, and we don't have time. And we even have time now because we are trying to package you for the global stage. So, co-judges, please let's put that as part of the recommendation for the general people. Thank you.
Good job.
Thank you, Victor. And next we have Teresa Jan from now University of Nigeria. And the title of her presentation is Comparative Study of Pyrolysis of Different Types of Plastic Waste for Fuel Production. Just hold on at the judge before you start.
You can just be filling it depending on what you okay? Just put in a slide that has the title and your names. Okay.
Yeah, we'll do.
Okay, Teresa, your time starts now.
You will agree with me that taking most Nigerian cities after every rainfall can lead into total eyesore. Flooded streets, not just the water, with millions of plastic bags, wrappers, and bottles, clogging our drainage systems, polluting our water bodies, and littering our environment. What if all this plastic waste can be converted into something valuable? Coal that can be used to power our industries, our vehicles, and even our homes. hope that could possibly reduce our dependence on fossil fuels, crude oil imports, and solve one of Nigeria's biggest environmental crises. Good morning, my name is Teresa Makama Ijani. I'm from London University of Nigeria, and I would like to explore with you comparative study of paralysis of different types of plastic waste for world production. Globally, we produce over 400 million tons of plastic waste every year. In Nigeria, we produce about 2.5 million tons of plastic waste, and only about 9% of this plastic waste is recycled, according to UNEP in 2023. Why is so much plastic used? This is because it's a remarkable material that has so many qualities that range from its versatility to its low cost and durability, that allows it to be applied in so many sectors such as agriculture, electronics, automotive, and etc. You're probably holding or wearing something made of plastic in this moment. Unfortunately, it is not biodegradable, and so much of it is being produced, and our current waste disposal methods are not effective enough to handle the bulk of plastic waste accumulating in our environment, which is causing a lot of environmental and health crises. Additionally, it is projected that by 2050, over 50% of the world energy demand have increased. Fossil fuels are still dominating, especially in emerging economies. In Nigeria alone, which is one of the major oil producing countries, in 2023, according to Nairametrics, we spent over 15.4 trillion naira on importing crude oil due to underperforming refining facilities. Populations are increasing, needs are multiplying, we need more. This highlights both a waste and energy crisis that my research attempts to solve using a process known as pyrolysis. This is a chemical process that happens in the absence of oxygen that degrades plastic to produce valuable products like liquid gases and solids that can be applied. So the aim of this research is to evaluate and compare chemical and physical properties of pyrolyzed fuel derived from polypropylene and polyethylene terephthalate with those of using our gasoline. This set out to answer two questions. Which of the two plastics have produced better fuel yield and quality? And can a low cost and abundant catalyst known as kaolin increase the fuel quality and yield? These were the objectives: to characterize the plastics using SEM index and FTIR, to produce pyrolyzed fuel from the plastics, to evaluate their yield and compare their chemical properties with those of using our gasoline, and to determine the effect of kaolin on the rate and yield of the pyrolysis process. These were the three most important papers that form the basis for this research. The gaps identified were used as a basis to form the research aim and objective. Here we have the research methodology used. First is the selection and preparation of the plastic waste. Then it was the plastic waste and the kaolin catalyst were characterized. Then pyrolysis experiment was carried out. The products were then characterized, and then the comparative analysis was carried out. The PP and PET plastic selector was based on a survey carried out by Akama in 2024, which indicated that polypropylene and polyethylene terephthalate were the two most single-use plastics, most commonly used single-use plastics on that university campus in 2024. They were selected, they were cleaned and reported to similar sizes. Then plastics and kaolin were characterized using SEM, PDS, and FTIR to determine their surface morphology, their elemental and chemical composition, and to see how these characteristics will affect the pyrolysis process and products. Then the pyrolysis experiment was carried out both thermally and catalytically on each of the plastics using a catalyst to plastic ratio of 1:3 and a batch reactor at the school engineering lecture. Here we have the results. First, the result of the characterization carried out. From the SEM result, you could see that the two plastics lack porosity, which means they probably have very high thermal stability, and the kaolin can be seen to have a layered structure and have porous faces, highlighting that it probably has a very high surface area and the ability to improve the yield of the pyrolysis process. Then PDS results also showed the elemental composition of the materials characterized. The PET was seen to have high oxygen content and high amount of aromatics and esters. So it has a very rigid structure, which means it has very high thermal stability and requires really high temperature and probably catalysts to produce the liquid fluid. We also found some other elements in it that we attributed to the additives or pigments added when manufacturing plastic. traces of iron, copper, and nickel that could probably enhance secondary cracking and could be attributed also to additives in plastic manufacturing. And then kaolin highlighted the presence of silica and alumina, which is expected because kaolin is a silica and alumina clay. It had a high amount of zirconium, which could possibly enhance the stability in the process. And iron as well, which would act as a catalyst in the pyrolysis process. Then SCR test results also showed that PT had a high amount of carbonyl and oxygenated compounds, which highlight that it possibly produce fuels that have high amounts of aromatics in it. The polypropylene had a high amount of aliphatic hydrocarbons, highlighting that fuel produced could possibly be more like gasoline compared to diesel. And kaolin also highlighted the silicon and alumina oxides, and also we found a high amount of absorbed water in it because the kaolin was not dry. After the pyrolysis experiment, first on PET, yielded no liquid fuel, even on its catalytic trial. It only yielded TPA, which is terephthalic acid, yellow solid that can be seen in the diagram, and char. Unfortunately, it did not produce any liquid fuel, but that does not mean that these trials were without value. The trials of the PP produced liquid fuel on both trials, the catalytic and the thermal, and it also produced a certain amount of water as expected because we saw water in the characterization of the catalyst. There was also minimum char production, and the char production reduced on the catalytic trial, showing that kaolin successfully reduced the amount of char produced in the pyrolysis of PP. Here we have a trend showing the liquid fuel yield or the liquid fuels of PP. The first trial yielded about 10% of liquid fuel, while on the catalytic trial, that's trial 2 and trial 3, you can see that kaolin successfully increased the liquid fuel yield by about 12 to 13%, which highlights that kaolin did successfully contribute to improving the liquid fuel yield of polypropylene pyrolysis. Unfortunately, you can see that there is a big difference between the liquid fuel yield in the research and that from literature. And this literature-based liquid fuel yield use the same temperature, the same plastic, and the same catalytic plastic ratio. This can be attributed to so many operational challenges with the reactor, such as lack of a proper condensation system because a lot of gaseous fuels escaped from the reactor. Also, it was a batch reactor, and the batch reactor does not really allow for proper distribution compared to other types like the gas bed or a continuous reactor that can keep adding plastic or catalyst to. Here we now have the comparison of density and viscosity of the pyrolyzed fuel of diesel and gasoline. The pyrolyzed fuel were seen to have density values that were closer to that of gasoline than diesel. They were very low compared to diesel, and then for the viscosity, you can see that it is very high compared to diesel and gasoline. This can still be attributed to the reactor conditions because there wasn't enough heat and proper distribution. Proper cracking of the polymers and hydrocarbon was not carried out. So the fuels produced had high amounts of heavier molecular hydrocarbons compared to that of polypropylene pyrolyzed in literature and that of diesel and gasoline. This does not mean that this cannot be applied. So many modifications can be done to so that it can be properly applied to diesel or gasoline engines, such as hydrocracking to further break down heavier molecular compounds or distillation, because the products will distill at different boiling points. Then the fuels also characterized using gas chromatography analysis. Unfortunately, I did not have the results by the time I submitted my slides, so I'm just going to speak to them. The gas chromatography provided the hydrocarbon concentrations in each of the fuels that were tested. These hydrocarbon concentrations spoke to the viscosity and density tested. We saw that in the fuels there was a high amount of aromatics and heavier molecular compounds, and especially in the polypropylene fuel that was gotten from thermal pyrolysis, there was a high amount of aliphatic hydrocarbons from C5 to C10, which showed that it is closely related to gasoline fuel. Then the hydrocarbon contribution was carbon concentration for each of the hydrocarbons found in the GCMS analysis, we're used to get a rough estimate of the octane and cetane number for the core, so we can compare it with these numbers. The first core produced thermally was seen to have an octane number of about 69, and then the second one had an octane number of 76, and they all had cetane numbers of about 25 and 20. So they were closer to gasoline. Gasoline had a high octane number of 90 to 100, and although there's a difference between the 60, 70 and the 90, like I said, modifications can be done to increase the octane number, such as catalytic reforming or fuel blending with fuels that already have a high octane number. Then, like I said, the trials of PT were not without value. The chart rules from the PT and the PP were characterized with SEM to check their surface topology and composition, see if they can be used for to solve other problems. So the chart from the PP and PT, the one from PP was seen to have a granular form, a granular structure, and high amount of carbon, as expected because it came from polypropylene, which had a high amount of carbon. And it was also seen to have some amount of nitrogen, and it was a very porous chart. So it could be used, it could possibly be used for water absorption and water purification to purify water. Then the chart on PT was a bit more consolidated. It wasn't granular, it wasn't as porous, but it still had a high carbon content, which means it could possibly be applied for energy storage as supercapacitors or electric vehicle batteries, and as catalysts for safe impregnated metal catalysts. So my recommendations for this research are to use calculated or acid activated kaolin on the PT analysis to further check if the kaolin has the ability to actually produce liquid form of PT. Then test the PT also with other types of polyolefins like polyethylene or polypropylene, because literature shows that when PT is mixed with other plastics and use more liquid form to further characterize the chart to confirm its applications. To implement mechanical support if you are stored with a battery reactor, so that you can filter out certain products like TPA to avoid clogging and operational challenges in the reactor, and to blend the forms produced as facility to properly test their combustion efficiency and condition. Parentheses offers us the opportunity to bolster our energy security, contribute to the circular economy, and create jobs in the waste resource sector. I believe that with proper implementation, policies, research, and technologies, we can exploit this untapped potential and change all this plastic waste to power, transitioning us into a cleaner and more sustainable economy. Thank you.
Wow. Teresa, good job. I like your disposition. You'll be a good lecturer. I like the fact that you also have a firm handle of your slides, which is good. Some of the little things we spoke to in the previous, she actually pointed that in her slides. Good job. So what will be your value proposition? You want us to stop drilling for oil, focus on...
But this can be like the transition for, since we are trying to use natural gas to slowly transition into a cleaner form. So we can start with this. It can be blended with gasoline and diesel so that we don't use as much energy as we're using to produce fossil fuels, because this is more energy efficient.
Okay, so you spoke to you wouldn't get enough yield because your reactor was not very efficient. I didn't see that in your recommendation.
Well, I just added that mechanical filters could be added in the event that you actually produce the solid products like TPA that was produced, so that instead of clogged pipes in the reactor, you can filter it out and then the vapor can condense.
So you can get some yield.
Yes.
So for now you didn't get any yield.
No, 2 trials now.
So your proposal is based on what other people have done, the yields that people have done. The yields other to watch now. You think the female youth. You know where I'm going to do that, right? So when we can talk about this after this. It's a good work. Good job. I like the idea. I like the fact that you have forward thinking. I'm sure most cities who are having the news consider that in way out. The judges can we just
Okay. Unfortunately, I was not around for a thorough check. But from my observation, you couldn't do it yourself, right? You relied on other people's papers, right? No. When I mean you couldn't do it yourself,
the result you got.
The results you got it for the what is that?
The yield.
The yield.
No,
liquid yield.
The liquid yield for there are two classes. So I got liquid yield from one, but I didn't get from the other one. So the liquid yield comparison and the properties are from the
So you got from one, you didn't get from the other one. So did you give any output for the one you did not get from?
I produced chart instead of liquid yield from it. So it was the chart I characterized to see if it could be used as an absorbent for water purification or for energy storage.
Okay, thank you.
Any more questions from the judges? Judge?
No, less.
Just finally, is nairametrics a reference? So you need to check that too. You use nairametrics in one of your referencing. I don't think it is. So take note. Oh, Prof, am I nairametrics?
Nairametrics is not even allowed.
I don't think that. It's from the internet, but it's just a web page with no author. But I don't know if it has changed now.
Can I just say something about it? No, it's just a general knowledge thing, so everybody's So if you look at APA 7th edition now, you can actually reference web pages and even unpublished work. So there are processes for that. Normally you can't, but as the progress are made, there are ways you can actually reference that.
APA, that's what type of
American Psychology Association. So that's where you have your author system, and then
is that a standard? Is that a standard?
Yes, it is.
Yeah, Prof. It's just that from many schools, they feel that it is more of a hearsay. The kind of materials they put in that website is more of hearsay. That's why it is discouraged. I've seen some good quality information in our metrics, but many times, most of this is just hearsay. So that's why
you have to reference it to say it's from there. So when you want to use that, you can guide yourself to say, am I taking this as 100% true, or I'm going to do another check?
Teresa.
No chance, but I'm still not in that school of thought.
When you take that off, right?
Teresa, you are present.
Thank you.
And next we have Abdul Badar from Bishop Ibadan. And the title of our presentation is Optimizing ESP Efficiency and Reliability Using Non-Dominated Sorting Genetic Algorithm 2. Wait for the judges to give a green light.
Just give us a few seconds. You can just be filling the Okay, that's the floor.
Good morning, everyone. My name is Ibaida Abdul from the SP University of Management, and today I'll be presenting a research work on optimizing ESP efficiency and reliability using non-dominated sorting genetic algorithm to shorten energy release. So, introduction. What are electric submersible pumps, shortly called ESP? ESP is an artificial lift system that are used to boost production in wells by artificially lifting this fluid from the surface from the well to the surface. So they are used in oil and gas production to boost well performance. But however, balancing their efficiency, how reliable they are, that means do they feel how reliable they are and how much energy they consume is challenging because most current optimization framework often focus on one over the other. That is, oh, if this ESP is efficient, it tends to like fail quickly. So while we're optimizing them, why is optimizing necessary? These ESPs, they operate in dynamic conditions where factors like the kind of fluid that is in the environment, the well condition, and how the power that is powering them can impact their performance. So when we do not optimize them, it can lead to them failing frequently and also not giving us the needed production that we want. So my approach is focusing on two optimization criteria: how efficient they are, how reliable they are, and how much energy they consume. So here is the diagram of a simple ESP system. What are my objectives for this research paper? In terms of projection, I want to assess and predict the impact of this multi-objective optimization on the efficiency of this ESP, their reliability, and also how much energy they consume. In terms of in the aspect of methodology, I want to be able to build a smart algorithm. I want to be able to build a smart and data-driven approach using the energy into algorithm that strikes a balance between these three conflicting objectives without compromising any of it. In terms of performance, I want to be able to evaluate my framework using an ESP performance data and compare them so that I could see how they perform well. A little bit of literature review. So going through online and checking through literature of what has been done as regards this work, I realized most of the work that has been done usually focus on one or more of these objectives. They do not look at the three objectives and how conflicting they are. That is why I decided to check this approach and balance the three together. Now let's look through my data set. So I was able to source data across various sources online. This data includes different optional parameters like the insular diameter, the flow rate, the pump intake pressure, current, and all these. So these all data, total internal set of 3,000 data points. So as you can see, my data set has a failure distribution of over 23% failure and over 70% of non-failure. This is to ensure that there is no bias and is actually accounting for failed ESPs. For my flow rate distribution, I have a normal flow rate distribution according to ESP data, and I have two types of ESP count in my data set with ESP 451 being the higher. It uses an approach of multi-objective optimization, that is, it can balance these three key objectives without compromising the other. Second, it gives me a diverse range of solutions, that is, it gives me like different possible set of solutions and allows me to pick one optimal one to design a robust ESP system. Third, it is efficient and it leads to like lesser computational cost. And lastly, it has been used in real-world engineering problems, making it a choice for optimizing the ESP performance. So I'd like to run through a high-level overview of how this algorithm works. So let's think of this as a smart automated optimization engine for an ESP. So at the initial level, we have different data sets of ESP configurations, which forms like the initial population here. So these data sets, these different ESP configurations are brought together and are evaluated using two things. First, how well do they perform? Is this one performing more than the other? And second, how different are they from the other sets of solutions? Then these data sets that I brought to the ones that perform the ones that I've evaluated that are brought together are then selected to form a new set called the parent set. So these new parent sets are combined together, are selected and combined together through what they call crossover, like in genetics. So they are combined and their parameters are slightly altered to generate a new set called the offspring set. So this process continues until we have the best solution, like the most optimal solution out of this. And in the process, the ones that are not performing are rejected. So my framework design involves what? Collecting my data, reprocessing them, doing some performance matrix calculation on the efficiency, the reliability, and energy consumption, using the algorithm to optimize the metrics that are listed out. So the algorithm optimizes the metrics and generates a set of solutions called the Pareto front. So the Pareto front are the set of solutions that this algorithm gives us. They are the most optimal solution that balances trade-offs between these three competing objectives. So here's a quick rundown of my results. So from the visualization here, the gray points here are represent each gray point represents an ESP configuration in my data set. So the red line points are the optimal solutions, the Pareto front, the optimal solutions that are balancing these trade-offs. So from the red front here, you can see some of the points. The point here is on lesser energy consumption. This is the energy consumption. This is the reliability. This is the efficiency. It's on lesser energy consumption, more reliability, and more efficiency. So this set of points here are like the best set of solutions that balances these three key objectives without compromising any of it. So in the other graph here, I evaluated based on what were the data before I optimized and what were the data after I optimized. So the gray points are what the data have before I optimized, and the red points represent where the data have now after my optimization. So in this graph here, so I picked a particular ESP set, a particular ESP, and compared how it performs pre-optimization and how it performs post-optimization. From the numbers here, you can see the efficiency improved slightly above 69%, almost close to 69%. The reliability increased like over 10%, and energy consumption reduced by 30%. These are not just numbers. These numbers gives a lot of economic advantages. Think of it now. If an ESP is improving more than 69% than it has done earlier, what does this mean? This means that we could produce more crude oil per the energy that we are doing, and this could lead towards production profitability for industry. In terms of reliability, if an ESP is becoming more reliable, 10% better than it was initially, what does this mean? This means that fewer workovers will be done on that kind of ESP, and also there will be lesser labor demand on it. In terms of energy consumption, we are getting like less than 30% energy being given out. And this is like one of the key things that we're advocating in the world today, which means lesser carbon into our environment, lesser carbon footprint. And this can help to improve companies' ESG policies. So these numbers are not just like numbers. They provide, beyond the technical details, they provide very great economic advantage. So what are the industry application significance for my research work? Firstly, in oil and gas production. This, if you optimize at ASP level, it leads to what? Producing more oil and ensuring that we have like sustained hydrocarbon extraction from our wells. Energy efficiency initiatives. We are currently in a world of energy transition and all of that. If you are able to reduce the power that you are generating through your operations, this will lead to reduction of the carbon footprint you are giving into the environment and align with the world energy transition goals. Thirdly, improved reliability means that we have lesser downtime in our operations, and this can help us to reduce maintenance costs and operational risk. Thirdly, fourthly, unconventional reservoirs. If we can optimize our ASP, it leads to what? The pump life to extend even in challenging environments. In unconventional reservoirs, optimizing our ASP leads to what? Extending the pump life, even in challenging environments like heavy oils and deep water. So, in conclusion, my work marks an advancement in production optimization in the current industry work by balancing these key objectives, efficiency, reliability, and consumption. It moves beyond the conventional rule that focuses on one of these metrics or rule-based model and offers a more robust, data-driven predictive approach for improved pump operation. Also, the ability to balance this theory operation will empower field engineers to make better decisions. They could look into this set of solutions and find the best one and make better informed and strategic decisions when designing these ESPs. Also, my work could also be conducted in more diverse well environments that could assess adaptability and refine the parameters for improved scalability and performance across various reservoir conditions. And thirdly, my work will be combined with more AI-driven predictive analysis that can enhance decision making, enabling it to be more adaptive for efficient ESP optimization. In summary, my objective was to do what? Balance this three objective using a multi-objective optimization framework. And my proposed solution was applying this MSGA tool to analyze this performance data and determine the best optimal solutions. And I aspire to improve ESP lifespan, to make them feel lesser, and to enable them to produce more efficiently while generating lesser power. And my results achieved was 69% higher efficiency, a 10% higher reliability, and a 30% reduction in energy consumption. In future, I could integrate my work into AI-driven predictive analysis and expand its optimization framework to detect other related ESP anomalies such as blast level for further instability and operational improvement. Thank you for listening. Any questions?
Father, as usual, good job. I like the fact that you had control of your slides. It's your slide and you didn't disappoint. What I see from what you presented is how to probably use machine learning to make an effective decision making in selecting ESP. I love your work because it relates to one of our recent projects we have in the field where we had to install an ESP after we had a wrong prognosis. The simple question I want to ask you is, if you want to sell this to a company, what would be your keyword? If you want me to deploy this multi-decision tool, what would be your keyword? If you want to convince me to use this, I call it your machine learning model, how do you convince me to go through your?
Firstly, the goal of every company is to make money, to make profit. So, using this framework enables them to select optimal ESP that can save them operational costs by just selecting randomly. It can save operational costs because it enables them to pick the best design that will lead to like higher efficiency, making it lesser downtime to not fail because they are picking a solution that will enable them to balance these trade-offs, that will enable them to balance this trade-off between this, how efficient will it be, how reliable will it be in terms of number of years that it will fail, and how much energy is releasing to the environment. So, and that's like the goal of every company now. They want to like reduce their carbon footprint. So my work now is taking these three key things that every company needs. They want to make their operations efficient. They want to ensure that they are not having higher downtimes, and they also want to release less carbon. So these three key things.
It's enough. So you're saving me real time. Once I go in and install, I don't need to go back again and start pulling out and finding out what the problems are.
Yeah.
All right, got this. Any question for me? What? Any question?
I think I just have a recommendation. In your slides are not numbered, so I think see any one slide. Can you go back a bit? Yeah. So really need to number as and it's really yeah, also my slides.
I'm actually more concerned when in case or in a situation where you are nominated or you qualify to go, is this the same presentation you'll be taking in the global stage? That's just where my fear is for, because topics like this I've been in the system for decades. So that's just my fear. But, well done.
Try and use less text, okay? Since some of your slides they are chopped up with lots of text, try and use shorter text. We just go through the 2 or 3 words and you speak out and explain it. You are suffocating rather than just reading from the this is the last place where you have to
The cheap learning. This is the cheap learning part. This is the cheap learning part that you should literally be experienced, but that's
Thank you very much.
So just one more feedback for you, because it's a good work. So ESP globally, there's a lot of research work. So in your presentation, please emphasize on the machine learning part, what you are bringing, which is good. So you need to focus more on that, and then the significance of the work. If you want to focus on ESP, nobody's going to listen because we have, thousands of materials on that already. But good job.
Thank you so much. Thank you, everyone.
Okay, and next up we have Dave Briggs from the University of Port Harcourt, and the title of his presentation is Sawdust Enhanced Spacers, Revolutionizing Clean Efficiency and Loss Circulation Mitigation in Oil Field Operations.
There's no clear. Funding
Yes, just click here. Pause it. The judge will tell you when to start.
Alright, well, I'm ready. Okay. Okay. Alright, the time starts now. Go ahead.
Good day, ladies and gentlemen. My elders scholars and the panel of judges.
Just a minute. It's an honor to welcome our incoming, our current Vice Council Chair, Mr. Francis.
Good afternoon, everyone. Apologies, I was just coming to attend the program, so I said I should come in here and see what you do. I really appreciate it. Thank you so much.
Thank you for coming. Apologies for that interruption. Please go ahead, Mr. Asman.
Good day, ladies and gentlemen. My elders scholars and the panel of judges, my co-paper presenters, and my audience. My name is Briggs Dailolo from the University of Port Harcourt, and I'm presenting on my paper titled Sawdust Enhanced Spacer, Revolutionizing Cleaning Efficiency and Loss Circulation Mitigation in Oil Field Operation. Okay, so my background. Now, my background I'm going to tell about my background, what made me think of my investigation made by BP, the British Petroleum Company, about what happened that day. And one of the causes of that accident, was poor cementing job. Now, further research will show that poor cementing job was caused as a result of poor cement integrity downhole, right? So now, further research will now show that some of the causes of poor cementing integrity are depending on your spacer design. That now leads to my research, spacer. Now, what is a spacer? A spacer is a field tailored for proper drilling mud removal, downhole, and for effective cement operation. So now I'm working on the spacer. Now, also that led to one of the causes that resulted to that accident was they were trying to reduce costs. They were trying to save costs. So now that led me to think of a way to come up with a spacer that is super cost effective. Now that led me to think of what we call the sawdust. Sawdust is an abundant underutilized byproduct of wood, mostly in the furniture and wood building industry. Now, going to my problem statement, which is cleaning inefficiency, cost inefficiency, loss circulation in spacer field. Now, before I move on to my aim, one of my intelligent and very, very intelligent lecturer said, whatever research you are doing from University of Port Harcourt, he said there are three things you should have in mind. The first is one, the performance, which is the outcome of whatever you are researching on, which is now we're talking about cleaning efficiency, the degree at which it's efficient. Two, safety. Now, the environmental impact, which is eco-friendly, sawdust. And three, the cost, which is cost effective. Now, let's move on. During research, I went through some papers and published by some authors. Now, researching year 2018 focused on fluid viscosity. Yeah, it was fantastic. He achieved a good cleaning efficiency, but he didn't focus on the cost of the material he used. Yes, performance was good, but the cost was not really nice. Now, moving on to the next, Graham Memorial, he focused on compatibility of the spacer and the oil-based fluid. Yes, he achieved a compatibility number that was great, which helped in the cleaning efficiency. Yeah, he got that, but he didn't focus on the loss circulation mitigation of that spacer downhole. Then last, after and far, he focused yes on loss circulation. He did that, right? But he didn't focus on the cost effectiveness of that material and the eco-friendliness of that material he used. Now, my methodology. I did an experiment, two experiments in the laboratory using API ROP 10 BP standard, and also I employed the biological method one, and also employed the high pressure, high temperature filtration methodologies. As you can see, these are my materials, the materials I used and the equipment I used. Now, the methodologies. I will not focus on my slide because I am my slide. I know any continent wake me up, I can say and defend my research. So this, I'll waste time here, but please listen to me. So now moving on, sawdust preparation. If that's the first step, right? You need to get your sawdust. Now, yeah, sawdust is gotten from all wood, but the question you should ask is, what is the optimal sawdust you should use for this particular design, that is spacer? Now, my research showed that the best wood to use is hardwood, mahogany. Now, when you use this, why do I say so? One is because mahogany wood has thin fiber, it is thick and also flexible. Two, it has high temperature resistance, that downhole temperature is very high, so it is effective for this purpose. Then two, it has high resistance to water absorption, unlike other woods. Then three, it has the rate at which it decomposes is not as other woods. So that is why I focused on mahogany hardwood. Now, moving on, after getting my sawdust, right, I grinded it to medium-sized particles. Then after that, it was dried and kept for my sawdust, and kept for the mixture, right? So now moving on to the next, spacer design, which we are all here to hear, the spacer design. Now, how did I design the spacer? Now, the spacer was designed, firstly, the base fluid, which is water. Then secondly, the anti-foam was added and the viscosifier was added. Now, this was mixed for 30 minutes to ensure homogeneity, proper homogeneity, right? So that's the best. Then after the wetting material was added, the extender and the mutual solvent was added to the mixture to complete the spacer design. Then it was now conditioned to 45 degrees Celsius using the atmospheric oscillometer in the laboratory. So after which, I now moved on to the next stage of adding the sawdust, and I now blended it up for 30 minutes to ensure proper homogeneity. Now let's go on to the next. Cleaning efficiency test. How was it done? Like I mentioned, I used the rheometer, right? The rheometer is like a blender-shaped equipment that has a rotor that blends whatever you want to put in the jar. So now the rotor of the rheometer was removed. Once it was removed, it was clean. Then it was now weighed to get our weight, W1. When it was weighed, then secondly, it was now immersed in the oil-based mold for 10 minutes to ensure proper coating of the rotor. Now, this is to stimulate downhole condition of the oil-based mold wetting the casing downhole, right? So after which it was removed and weighed and gotten at W2. That's our weight 2. Then the last step was it was now put into the design spacer, and it was now the rheometer was set to an RPM of 100. Then it was now turned and it was now rotated. This is to simulate the effect of spacer removing the oil-based mold downward. Now, that is for cleaning efficiency. We'll get to our result. Now, moving on to filtration control test. I used the HPHT, high pressure, high temperature filter press equipment in the laboratory. Now, it had a jar. The jar was removed, and I selected a 2 mm slotted disc. 2 mm slotted disc was used to simulate the fracture of the formation. So let's look at this. It has a hole there to simulate the fracture of the formation. Now it was inserted into the jar of the high pressure, high temperature filter press. Then the spacer already designed was poured inside. Then it was now closed and secured and fitted into the HPT filter press. Then it was kept. Then the nitrogen hose was opened. Now the nitrogen hose is the pressure acting is to simulate the, because it's downward, in order to pump your spacer down, you need pressure, right? Now, the nitrogen hose acts as the hose to release the nitrogen to compress the spacer downward using the pressure regulator. So this was kept for 30 minutes. After 30 minutes, the spacer was removed and the filtrate volume was gotten. Now, let's move on to results. Now, how do we calculate the mold removal efficiency? That is one of the aim, mold removal efficiency. Now, mold removal efficiency is comparing what was and what is. So now, it is the ratio of the current, it is the ratio of the mold removed to the mold that was there times 100%. So that is how you calculate efficiency. So now this was done for 5-minute interval, 5, 10, 15, 20 to 5 minutes to get the efficiency at different time readings. So from the formula you can see our efficiency. Then moving to our table, you can see at 5 minutes the conventional spacer had 51.16 efficiency. Now at 25 minutes it had 77.5 minutes efficiency. Now let's go to the sawdust enhanced spacer. This is sawdust enhanced spacer. At 5 minutes, it achieved an efficiency of 73.71%. Then at 25 minutes, it achieved an efficiency of 91.92%. Now let's move on. This is a bar chart showing a close comparison between the sawdust enhanced spacer and the conventional spacer. Now this is the result for the cross circulation test. As you can see, it is to calculate the filtrate reduction efficiency. Now you need to know how well your fluid is reducing filtrate or loss circulation. This is the formula. Now discussion. Sawdust abrasive texture and fibrous nature. Now I would like us to have something in mind. Sponge and soapy water combining together. Now with that concept in your mind, let's move on to what I said. Sawdust abrasive texture. Now the effect of sawdust acts like a sponge to scrub the casing, thereby increasing cleaning efficiency because of sawdust fiber nature. Now the hydroxyl group in sawdust also weakens the bond downward because sawdust contains cellulose. Cellulose contains hydroxyl group. The hydroxyl group in sawdust tend to react with the hydroxyl group downward, thereby reducing the adhesion of oil-based mold. Once this is reduced, the effect of the fiber nature of sawdust removes the oil-based mold stuck in the casing. Now, this is the same thing. Interlocking. The sawdust particles tend to interlock, thereby creating a strong seal in the fractures of the formation. Now, also, in addition to that, it enhances viscosity and suspension ability. Now, this is another added functionality of that sawdust enhanced spacer. It has the ability, because of the nature of the sawdust, it suspends other additives once it gets to the fracture of the formation, thereby preventing loss circulation. So now, conclusion. This is competitively viable at the lab level. Now, what do I mean? Forget my slide, listen to me now. This thing is, at the lab, during the lab test, the sawdust enhanced spacer was able to perform effectively as the current spacer and was able to perform higher. So what is left is industrial application, that's at lab level. Now, cost effective. Now I'd like to talk on this. This is the main goal. Now, cost effective. Despite the sawdust being very cheap, sawdust is very, very cheap. 10 kg of sawdust is around 15,000 naira. And guess how many kg of sawdust I use? 5 grams, not a kg. So if you do the mathematics right, I'm talking about 10,000 grams of sawdust is just 15,000 naira. So you can see the cheapness of the sawdust. That is one. Then two is the sawdust spacer possesses functionality of majority of the additives already existing in the spacer. The viscosifier, it has the function of viscosifier. The clean efficiency, it has the function. The low circulation material has the function. So majority of additives already has the function. So once you adopt this sawdust enhanced spacer, you will reduce the quantity of other additives down, thereby saving costs. Very drastically saving costs. So that's why I'm saying that my sawdust enhanced spacer is cost effective, it's eco-friendly, sawdust have no harm, and it's and all that. So recommendation, I will recommend offshore laboratory tests. Now let's go higher. We have talked about the land and field. Now offshore laboratory tests. Now I recommend field trials and application. Then I also recommend preparation for large-scale packaging of sawdust. So with this, I'd like to say thank you for listening. It was a great honor presenting for you.
Bricks. This time around, you look like a pastor, as if you're just preaching. I like your passion, I like your, but then at the global stage, you need to reduce your mannerism, right? You're speaking to diverse ethnicity. You need to just go straight to the matter at hand. Okay, just show some level of professionalism. That was what helped a lot. Okay? I like the fact that you have a very good handle of your slides. You're probably one of the presenters that have shown that you don't necessarily need the slides. It's your work. You know, you went to the lab. We can see that you have the results in your finger, which is also very, very good. Okay. My only concern is that your sawdust is not, your proposal, you're not just saying use sawdust, but you're saying use a specific type of sawdust. So it's not readily available or cheap.
Yeah. Okay, thank you.
So how do we manage that? Do we go to capital workshop and start asking them, please, which wood are you using for, so that I'll know whether it qualifies for the kind of sawdust that I need to use, or you want to generate the sawdust yourself?
The sawdust I use does not actually have research, but for the common wood that is used for furniture. So I'm just saying, if you want to boost it, like get like close to 100%, you can use hardwood, but normal sawdust is the one I use, achieve 91.9%.
That is also you are just estimating until you do the proper experiment with hardwood. Then you have empirical fact to show to us that hardwood is better. You are just trying to say, oh, because you use softwood, you got this result. If you use hardwood, you get a better result. It doesn't work like that in science. Okay? But good job. I love your work. Good job. Judges, please.
Thank you for your presentation. As earlier stated, you have the control of the work. There are something that I like that you modify that one particular to the other people as you say it. And also from your slides there's not the aim and objectives those are listening, and also we need to characterize, do characterization and find out what reality are you going to tell us that this is a spacer. You don't have any evidence, scientific evidence to show that. So you need to characterize, you need to characterize the source, characterize the source, characterizability of what you try to produce. That will minimize cost. And also the implementation of the design. Design to produce change your spacer. You use them design tools. These designs that allow you to minimize the time specification.
How will you present literature you signed, they are very old. The oldest was current is 2008. And you won't tell us that they are not been able to work on this from 2008 till now. So look for more current literature in 2020. That was the beginning. But you have a presentation and that's your work. So, but also limit the number, limit how you tell your audience to look at you and complete the slides. People who already know that you are presenting your work, not by intention. Thank you.
So, in the global stage, you can't bamboozle anybody. They are more concerned about your technicality. Then secondly, why sawdust? If you have to tell somebody to be using sawdust, you know what oil and gas is? It's huge. Can it stand the test? Is it sustainable? Is sawdust sustainable? And you even say mahogany to be precise. Is that sustainable? When you go there, those are the questions because these people want cutting edge technique to be able to improve on standards. So I'm also afraid with your topic too on presenting this in Houston, Texas. That's my opinion. Thank you.
So just one last comment. Like, just keep repeating ourselves like normally. So almost that was just sometime and you are
1970, and you are talking of the Gulf of Mexico oil spill. 70. And when you compare it with what you claim you are interested in, the Gulf spill in Gulf of Mexico in 2010, do you know the difference in 30 years? 40 years. 40 years. Oil has evolved too long for this. So please take note, don't go and be using, if you want to use all these 1970s, these are going to be traditional issues. In management, we call them management by objective. When standard issues. But it's a good job. We wish you well too.
all the best. Thank you.
Please, I hope you're all taking this feedback from the judges on board because, as you know, Africa is the defending champion for SPC. Ifeanyi, who won last year after SPC, went on to win the international at ATC last year, so he did a fantastic job. And I tell everyone that he did his presentation online because he didn't get his visa. And he meets the students that were in the building at ATC. And these guys came from some of the best universities in America. So you guys have a huge job ahead of you you need to step it up if you're going to go to ATC. Also judges, we're halfway through, so we've done 6 presentations and I've got 6 left. Now, I don't know if I want to take a quick break, but we know that there's the Friday prayers today, and that, so we need to leave for what time? 1:30, right? Friday prayers at 1:30.
No, continue before then. Let us take 5 minutes or 2 minutes stretch.
So yeah, let's just take the judges, what stretch it is at 2, 5 minutes. They'll take like 5 minutes there. Then we'll go to the next part.
Yeah, we'll finish before that prayer.
Yeah, let's try to pass through and just wait.
No, we cannot pass it
We'll
through.
finish it.
We have to be fair to all.
Yes, we've got 6 left.
If he needs us coming back, I think we're okay with that. We can stretch, but taking 6 in the next. Is it realistic? No, we have to be fair to all of them. We have to give what is. So we can't give this one 1 hour, 20 minutes, and rush it.
Yeah.
So I put the queen by one.
For one.
Yeah.
So,
But just actually, yeah.
okay. So,
Only actually cut out for.
okay. So we'll see how many we do before then. They'll have to come back after prayer. Okay.
Let's take as many as we can.
Yeah, then go for prayer. Yeah.
Yeah, because we're ready.
Sorry for coming. Yep. What? Yeah, man. You know what it is? When you come back for the announcement, you know what it is. Well, maybe you get to separate different. Yeah, maybe tomorrow, then announce it tomorrow, right? Okay.
streaming.
So, next up we have Abdulafiz Dosmu from Nile University of Nigeria. And the title of his presentation is Production Optimization in Mature Assets, Leveraging Integrated Modeling Tools to Enhance Asset Performance. Alright, wait for the judge to give me the green light.
Just give us a second to just pick your name and then give you guys, okay? You can just be trying out and point a while.
Now.
All right, just one time starts now.
Good morning, judges and my fellow students. My name is Dosmu Abdulafiz. Yes, presents my paper topic, Production Optimization in Mature Assets, Leveraging Integrated Modeling Tools to Enhance Asset Performance. So this will be outline of the presentation. So what are mature assets? Mature assets are assets in oil and gas that have passed the peak of their production and are now in a stage of decline. This stage of decline presents many symptoms such as increasing water costs, reservoir depletion, and a general reduction in asset performance. But these mature assets contribute about 70% of the fossil fuels used in today's world, which means we still need to produce from these assets. So we are presented with a problem. As time goes on, producing from these fuels economically becomes harder and harder. So we need to enhance the assets. To enhance the assets, we have production systems which comprise of various components from the subsurface to the surface. So one might think that to enhance the production system, we just need to enhance the performance of each component in isolation. But then the enhancement of the components without considering their interaction leads to suboptimal enhancements or even no enhancements at all. So this is why we need to leverage integrated modeling. Integrated modeling models the components of the system and their interactions. This allows us to have a more representative understanding of the behavior of the system as a whole. So we have the problem, challenges that oppose the production from mature assets and limitations of existing methods. Industry standard tools make use of special progressive programs, the non-linear programming algorithm, optimization algorithm that is deterministic and depends highly on the engineering judgment of engineers. So there's need for a hybrid approach that integrates carefully for better exploration of spatial space and allowance of the less skilled engineer. And then there's no accounting for emissions such as gas flaring or CO2 So this is a literature I agree that help guide my methodology and the flow of my work. I just began by integrating PVC considerations into my pipe considerations to ensure accuracy because the previous paper I used in this course which does not account for the changes in properties that are usually associated with PVC properties. The second gap I am addressing is to include the economic and sensitivity analysis optimization results to assess the stability of the impact. Then the third one is that does not incorporate artificial intelligence mechanisms to simplify the model. I've provided one to better address security conditions. So my motivation methodology involves initial assessment of my wells and data and ensuring that the well data is verified and validated. So the next step is to model the wells and then surface transition. So then connecting the components to ensure that there's a good understanding of the interactions between the components. So optimization and solution development. I'm making use of an algorithm called particle swarm optimization to the other solution. So the algorithm was developed in Python and then implemented optimization solutions and then reporting and documentation. So yes, transfer optimization is a definition-based heuristic algorithm modeled after the behavior of flocks of birds in their search for resources. It involves the communication of candidate solutions in the search phase by evaluating their current solution and their fitness between the current solution and the ideal solution, and then the experience of the other candidate solutions in the search phase. So it helps balance the exploration, which is the effect of its own experience, and the exploitation of the effect of other candidate solutions in the search phase. It's skilled for handling complex multi-step optimization problems like the ones we have at hand, and it is not as computationally intensive as sequential programming. So the key components that affect the algorithms effectiveness are sum size. Sum size is the number of initial candidate solutions in the search phase that are randomly generated. Then the initial weight is the tendency of the candidate solution to move towards a better solution based on its own experience and the other solution's experience. And the acceleration function increase affect the initial weight to determine how much the candidate solution will approach the other one. The constraints that affect are the constraints of the material aspects, such as the production pressure limit, production rates, water cost, and processing capacity. The objective function is to maximize net present value and while balancing production rates and emissions. So, for a simple optimization problem that I implemented the algorithm to test its effectiveness and its reliability. So this is two graphs showing the convergence of solutions for iterations for the same problem, with the different number of iterations. And then this solution can be the number of iterations. So as the number of iterations increase, the solution can increase as well. Then the effect of sum size of final solution. So the sum size, as I said, is the number of candidate solutions in the search phase. So the sum size, and increase the sum size allows for a better iteration of the solution space. And it's see that the final fitness value is the fitness value is the difference between the measured solution and the optimal solution. So as the sum size increases, you can see that there is a reduction in difference between the candidates and the ideal solution. This is a sensitivity analysis of NPV key parameters. So the NPV is net present value to quantify the feasibility of a project in the future, the profits of a project in the future. So the key parameters are used the reservoir pressure, water cost, PR, oil price, and producing cost. Okay. So this is the starting point, the original actual values. So as you see that the parameter change, these parameters as they change, increasing 6.5%. You can see that the slopes of the NPV are different. So the parameters with higher slope show a more sensitive reaction to change in the parameter. So the analysis of my algorithm performance, conversion to AS should be stable, and the change of the same number of iterations and solution accuracy is minimum past 400 iterations. Adjustments are being made to improve efficiency, such as adapting initial weights. Initial weights to react to the closeness between the current solution and the ideal solution. Any stopping, if key conditions are being added, so that in case of a minimal change in solution, you can stop early to avoid waste of resources and time. The hybrid search shows to be combining the sequential processing programming and particle optimization. And then, for the solutions that I have, the
solutions exist, but it cannot realistically be implemented due to sharp changes in choke sizes and sharp changes in choke sizes can cause well instability and sound reduction. The next step is to deploy and tune and PS parameters for stability and for extended sensitivity analysis of economic factors. The expected outcomes are going to be fully functional automation framework integrating the industry standard tool and PSO to allow for a simpler implementation of automation and the guiding methodology that can be applied to real world field development and then the implementation of the insights and best practices for production automation. To conclude, leveraging integrated models is important to better understand and reflect the interaction of components in the system so that we can have a real idea of how to perform decisions and thank you.
Okay. Those who you are very gentle. You know. My feedback is that you have a very good topic, but you did not speak to the meat of the matter. The essence of your slide is to look at production optimization of a mature field, which is very, very valid, using PESO, right? You did over 400 iteration. I was thinking we'll see the data sets that were used for that iteration. Yeah. I'm also sure you also use a multi-criteria decision tool or model. I didn't see the criteria. What are you looking at? Okay, then the next I saw was you are doing sensitivity analysis. I didn't see the econometrics. So what are you doing the sensitivity analysis on? What is the MPV, for example? What is your before you do MPV, you should have the cash flow. You have a cash flow, do your cash flow analysis. I didn't see that. So it's a good topic. I felt you would have killed it, but you didn't really manage to bring out the juice in your slides. What happened? You didn't sleep well.
I wasn't sure I was putting too much to the.
Or you had it, but you left it. You just brought some few things. I can tell you have something, but we didn't really see any of such. Okay, judges, let me allow you.
You have this, like you said, it's a very good question. Do you have a supervisor that works with you? Did you show where you supervise by someone?
Did you show this slide to your supervisor?
No. Yeah, yeah, because the presentation is just quick and you mean where you want to connect them to be. Not technically presented.
And you study your project. Is this what you're working on in the project? This is what you're working on the project. That means you have a project supervisor and we didn't show you this work as 100 or 1% sure.
No, Prof, he has the work. But this slide is because of this slide.
The slide is just not, it's not, giving the vibe of what we are presenting, understand? The conclusions are even missing. No references. Can you go back to that story?
So what it said, go to, but this one is too boring. Go to the introduction. Your sliding is extremely poor. Now on this, look at the introduction, who and what are you presenting here? And you go to conclusion, you just put conclusion and this was blank. This slide is, if there is a mark that is -1, that's the mark you will have for slide presentation. Your sliding is very, very poor. You have a good talking box, you do not tell us the exact thing you did, and you do not, you should just put your slide. So that is very, very limiting. So you have to work on this more than what you have presented. Look at just the slide. What is the message you have presented to us in the introduction? So you have to tell us, give an overview of what you want to do or what you are doing. But this is not, this is not an introduction.
Just a comment. I think there was a lady that presented from lab. Yes. Teresa also.
Teresa, they've been doing so well. From same school. The supervisor didn't see this slide. Even his prof here. If his prof has seen this slide, he wouldn't have allowed him to.
Do you know her? Do you know her? Let's speak with her. She should guide you. I think very, very good.
Is this your first time doing outdoor presentation? Is this your first time doing outdoor presentation? Outdoor school presentation? Okay. So you have a lot to build. Good job, you did well.
Even though it's the school, I think you should have presented probably IT defense or some other defenses from the school. Comments must have been raised on that.
You did serious defense.
Yeah.
You do it by presentation, slide presentation. Let's have the next person.
All right, thank you. God, well done.
So hopefully practice makes perfect. Okay, so next up we have all the way from Tanzania, we have Avid Edward Cosmas from the Dar es Salaam Maritime Institute. The title of this presentation is A Novel Hydrogen Production from Natural Gas via Methane Pyrolysis, Achieving Net Zero Carbon Emission Targets. Clap for him. All the best.
Okay, just give us a second before you can start, okay? Just a second. How do you pronounce your, is it Cosmos or Cosmos? Cosmos. I know there's a Cosmos. George, are we ready? Okay. Go ahead.
Hello, my name is David Cosmos. I'm a second year student at Dar es Salaam Maritime Institute in Tanzania. A novel hydrogen production from natural gas via methane pyrolysis, an approach to net zero carbon emissions target, is the title of my research. So currently, the world produces hydrogen from mainly steam methane reforming. But steam methane reforming substantially contributes to emissions of carbon dioxide of approximately 9 kilograms per every kilogram of hydrogen that is produced. So my biggest quest was, how can the natural gas industry produce hydrogen without carbon dioxide emissions? So that basically made me delve into research into one of the uncommon methods, which is methane pyrolysis. Methane pyrolysis is the thermal breakdown of methane at very high temperatures in the presence or absence of any catalyst. So, delving into that research, I had two objectives. The first objective was to analyze the efficiency of hydrogen production by methane pyrolysis, and the second was to assess the potential of methane pyrolysis in reducing carbon dioxide emissions while producing hydrogen. I did set up a small laboratory experiment just to examine methane pyrolysis at a small scale. And so I designed a small reactor that would help me to achieve this methane pyrolysis. To achieve hydrogen using methane pyrolysis. And so I introduced 1,000 grams of methane, which is approximately 1 kilogram of methane. And the reactor was at 600 degrees Celsius. And I introduced then nickel, and then I raised the temperature to 750 degrees Celsius. And the reaction was the normal reaction that you guys are used to it. It's an endothermic reaction involving the breakdown of methane into carbon solids and hydrogen. So after that reaction, I did correct my hydrogen and carbon solids. But as I said in my objectives, one of my objectives was to analyze the efficiency of methane pyrolysis. So out of 1,000 grams of methane that I introduced into the reactor, I managed to convert 600 grams of methane to hydrogen. And from the mass spectrometer that I had, I saw the purity of hydrogen that was produced was 95%. And out of the same methane, 1,000 grams of methane that I introduced into the reactor, 300 grams of each were converted to solid carbon. So I did this 4 times. So on average, those were my results. I converted 680 grams of methane into hydrogen, and 300 those grams of methane into solid carbon. So I also wanted to examine methane pyrolysis at large scale, and I did this through survey because the materials were very expensive for me to achieve them, to get them. So I sent this to a simulated setup. I had this setup. So the setup I did was I conducted it at one of the second largest natural gas processing plant in Tanzania, which is the natural gas processing plant. And so my first was, how can a plasma pyrolysis reactor be integrated into this plant to enable it to produce hydrogen, if at all hydrogen was to be produced. Though hydrogen is not produced currently at that plant. So my simulated setup involved the introduction of 10,766 grams of methane into that reactor, and the reactor was at almost 700 degrees Celsius, and the reaction was the normal reaction, just like at the at the small scale. And I collected the hydrogen and the solid carbon that was generated. So it wasn't carbon dioxide again, it's the solid carbon. And so out of what I introduced, which is 10,766 grams of methane, I managed to convert 10,200 kilograms into hydrogen, and solid carbon was almost 476 grams out of 10,766 grams. So I did this only 2 times, and those were the average results that I obtained. So just like my objectives were, so I had to analyze the results, and I realized that conversion of hydrogen, conversion of methane into hydrogen using methane pyrolysis at small scale and at large scale, which at small scale was lab scale catalyzed methane pyrolysis reactor. It is, the conversion was almost at 95% efficiency, and at large scale it was 95 again. So almost there was equalization. And the carbon dioxide emission is that there was no carbon dioxide emission because methane pyrolysis basically, like from what I forgot, it involved production of solid carbon only and not carbon dioxide. So I also analyzed the economic and energy considerations here. So the first experiment at small scale, I used about 8 kilowatt hours of energy. So that was on average, of course. There was a range of 7.8, then 7.9, 8.0, and then 8.0. So on average, that is what I managed to obtain. And then for the 2 times that I conducted experiments using that simulation, I used 200 on average. So that one proved to me that methane pyrolysis while producing hydrogen as one of the cleaner fuels. I think the environmental impact of it will be very much positive, both at large scale and at small scale. So any good method should always be economically viable. So I realized that using renewable energy, as I said, at small scale, I used solar energy, 8 kilowatts of solar energy. So using renewable energies and carbon byproducts marketing, this carbon, the solid carbon that is produced here can be used to make batteries. It can also be used to to make construction materials like bricks. And I tried to make one of the bricks, of course. I did not make the battery. Right. So this can prove to us that even the materials that we have here, these carbon byproducts can create an extra income stream to the natural gas sector if at all methane pyrolysis is to be integrated in hydrogen production. I also realized, because I didn't have so much of automation to this process, but automation basically would reduce the cost of methane pyrolysis. So that makes it very much economically viable and doable. At small scale, methane pyrolysis is doable, but at large scale, the industry needs incentives to make it practical, and if conducted at small scale, it would help also to access clean energy, which makes that makes it very relevant to the current situation that we have. From the experiment that I did, the conclusion that I obtained is if methane pyrolysis is to be integrated into the current infrastructure of natural gas that we have, for example, in our environment in Tanzania, it could help at least meet 30% of the green hydrogen demand that we need, the projected green hydrogen demand that is needed for the next 20 years. And also, globally, the global hydrogen demand is almost 500 million metric tons. So integrating this methane pyrolysis into production of hydrogen instead of steam methane reforming will help getting this. And also, as I said before, that the carbon byproducts that are produced from this solid carbon, these are very marked up products. So they could create an extra income stream in the natural gas sector. So I recommend the governments and the stakeholders to mostly invest in renewable energy, because that is what will make it very much cheaper to run, and also the power optimization technologies that will help making it very much sustainable. That's it. Thank you.
Everyone, good job. You did a fantastic job. You were concise within time. You had a good handle of the slide. So this hydrogen that you produce, is it white hydrogen or blue hydrogen or gray hydrogen? Where do we classify it? This one is from using pyrolysis.
Green. It's green because, as I said, for the first time at small scale, I used solar energy. So basically, there was